Hey everyone, Mr. Allen here. I'm going to run through some Venn diagram exercises. So Scott and Dave are trying to decide what to get on their pizzas. The circles indicate the toppings that Scott wants and the toppings that Dave wants. And of course, the intersection here is the toppings on which they agree. And so it says Scott wants these, Dave wants these. And so basically we can place them. And of course we have to share this section here. And so just making sure we understand what it says. How many of Dave's toppings will Scott not like? Okay, so Dave has essentially 5 toppings, 2 of which Scott also likes. That means there are 3 that Scott does not like that Dave does. How many toppings will they agree on? This one should be pretty obvious. This intersection again, this section that overlap is where the toppings that they both like appear. And if they both get what they want, how many toppings will there be? Again, pretty straightforward. We're looking at 1, 2, 3, 4 things that Scott wants that Dave really does not, 2 on which they agree, 3 that Dave wants that Scott doesn't. So that's 4, 5, 6, 7, 8, 9 toppings total. So let's look at the integers 1 to 15, and we're looking at which numbers divide by 2, which numbers divide by 3. And so how many numbers in our set are divisible by 2? So here, of course, we're looking at the blue circle and the overlap. 1, 2, 3, 4, 5, 6, 7 numbers are divisible by 2. How many of them are divisible by both 2 and 3? So again, here we're talking about the overlapped section. There are just 2 numbers divisible by both 2 and 3. And how many numbers are only divisible by 2? Well, this would have to be the difference between these two. There are 7 numbers in the division by 2 group, 2 of which are shared with the 3, and so there are 1, 2, 3, 4, 5 numbers that are only divisible by 2. So here, how many students in the class are only on the volleyball team? Well, we can see that there are 8 students playing volleyball. It says that is here as well. 3 of them happen to be playing basketball as well, and so there are 5 that are only on the volleyball team. How many students belong to either of the teams? So just to be clear, mathematically or includes both. So when you see volleyball or basketball, it's this 5, these 3, and this 10 altogether. And so there are 18 students who play on essentially at least one of the teams, so the volleyball team or the basketball team, and then again, or both is automatically included in that. And how many students do not belong to either team? Well, there are 29 students in the class. 18 of them play on at least one of the teams. 29 minus 18 leaves me 11 others who play on neither team. (863) students total. 33 are on the chess team, 9 are on the chess and the debate team, and 27 are just on the debate team. How many students make up these 2 teams? So again, if they're going to be on the teams, they can be on one or both of the teams. So there are 33 here, plus 9 is 42, plus 27 more is 69 students total on one or both of the teams. How many students in school are not on these teams? Well, again, 863 students total. Subtract this number, that gets me to 794. And yay, we got 11 out of 11.